Hi students, welcome to Science. In that, Science chapter wise revision. Okay, children, in this I am doing chapter wise revision, but majorly I am just highlighting the important topics or important lines or important paragraphs from where the questions can be asked for your board exam from this chapter. Is this clear? I am highlighting the important topics. Maybe those questions can be asked for 1 mark, 2 mark, 3 mark, 4 mark, or else for 5 mark also. Done? Now let me start chapter wise revision highlights. Let's begin. This is our first chapter, chemical equations, chemical reactions and equations. Let's start chemical reaction and equations. Dear students, I just want to tell you that when we solve any chapter or when we refer any chapter, what we do, usually what we do, we start from the first line, right? We start reading this. Consider the following situations of daily life, correct? We start reading this sentence, but that is wrong. What you should do is, first we have to go for the last page of this chapter. Remember this, whenever you study any chapter, this is the way and this is a procedure to read any chapter. So what is the procedure? First what we should do, we have to go to the last page of this chapter. We need to go to last page of this chapter. Okay, we can. So this is the last page. Please read these all points. Definitely you will get question. Okay, some number of questions, okay, will be coming from this last page. What we have learnt. Is this clear? Can you see here? A complete chemical equation represents the reactants, products and their physical state symbolically. A chemical equation is balanced so that the number of atoms of each type involved in a chemical reaction are same on the reactant and the product sides of the equation. Equations must always be balanced. In a combination reaction, two or more substances combine to form a new substance, that is known as combination reaction. Decomposition reaction are opposite to combination reactions. See here, we have got one more new point. So what is that? Decomposition reactions are opposite to combination reaction. So in this way the 1 mark questions will be chosen. Be careful. This is one point we have got. We call opposite to decomposition reaction as decomposition reactions are just opposite to combination reaction. In decomposition reaction, a single substance decomposes to give two or more substances. So reactions in which heat is given out along with the products are called as exothermic reactions. If heat is absorbed, then it is called as endothermic reaction. Okay, and next we can see here. After this, what has been given here? Heat energy is absorbed or known as element in this, and reactions also involve the gain or loss of hydrogen by substances, that is oxidation is gain of oxygen or loss of hydrogen, oxygen or gain of, I think you can open your textbook. I want you all have to open your textbook and keep it ready with pen or pencil something so that you can highlight it. And apart from that, you have to keep one more A4 sheet, blank paper. You have to make a note of each and every point what all we are discussing here. Is this clear? So please start any chapter so that you will get to know what all the things we are going to study in this chapter. Everything is given in these points to remember. So this is very, very, very important, and even maximum make sure that the question paper setters will choose the question based on the idea of this last page itself. Okay, question papers will be setted based on the idea of this last page. Do remember. So you should know the basics. Got it? Very good. Now let me start the chapter. Chemical reactions. Now the following situations, you can see some situations has been given. You all think you people can read this all following whatever it has been given. But my concept is I just want to highlight the topics what is required for your exam. Okay, so you want to study the entire book, but still you need to remember these things. Now what we are discussing here. Done? Okay. See children, here we can see one figure. Can you see here? We can see a diagram. So what is this diagram says in activity 1.1? Can you all see this diagram? Yes. That is nothing but burning of magnesium ribbon in air and collection of magnesium oxide in a glass. That is nothing but we are burning the magnesium ribbon in air. When magnesium reacts with oxygen, air is nothing but oxygen. What it produces? Magnesium oxide, right? Yeah. Now here what type of question you will get usually? The very important point in this chapter, the first important point, please highlight it very importantly. Magnesium ribbon when burns, can you see this? When magnesium ribbon burns with a dazzling white flame, when we burn the magnesium ribbon, which type of flames are produced? White color flames are produced. And what color of powder is, what type of product is obtained? That is white powder. The product is white powder. So remember, we get which type of flame? Color of the flame? White flame. And what is the product? White powder. So this is one important. So this magnesium oxide what we have got, the magnesium oxide what we have got, that is nothing but white powder. So remember this is question number 1. Understood? When we burn the magnesium ribbon in air, it produces magnesium oxide. When it produces magnesium oxide, it produces a dazzling. Dazzling is nothing but shiny color, okay, shining. White flame is produced and it changes into white powder. Did you understood this? So this is one important question. And after that, come back to the next line. If you want to say any chemical reaction, I will give one substance to you. Okay, take this. I have given one substance to you. Okay. Now, let me know in this whether chemical reaction has taken place or not. How can you tell? Okay. How can you say that whether the chemical reaction has taken place or not? How can you say that? It's very simple. See here. If you want to say whether the chemical reaction has taken place or not, it has to satisfy certain conditions. Either we have to see there should be change in state or change in color or evolution of gas or change in temperature. So these conditions are very important. Out of these conditions, any one condition also satisfies, okay, there is nothing but chemical reaction has taken place. Got it? Okay, but here I am not going to explain in deep because we don't have sufficient time to explain, elaborate each and everything over there. So you just need to remember this. Got it? Okay. Next topic. See here children. Here we can see there is a figure here. Can you see this? Formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Here the question will be asked for you like this. What happens? Okay, when dilute sulfuric acid reacts with zinc? Okay, that is usual question. Write the balanced chemical reaction. But here the question is, when dilute sulfuric acid, when it reacts with zinc, which type of gas is evolved? Which type of gas? Hydrogen gas. So you should be careful with this question also. It carries 1 mark. When dilute sulfuric acid reacts with zinc, okay, so what happens? Which type of gas is produced? Hydrogen gas is produced. Even this question is also very important. Is this clear? Very good. Next, come back to the next slide. I want you all have to mark in your textbook, as well as you need to make a note of these points. Okay, these all are very important questions. Next, this you know very well, when magnesium reacts with oxygen, it gives magnesium oxide. Okay, done. Next, writing the balanced chemical equation. They may ask you to balance the chemical reaction. I hope you all may be knowing this. So remember this reaction. When zinc, when Zn, that is nothing but when zinc reacts with sulfuric acid, what happens? So it gives zinc sulfate and hydrogen. You have to balance this chemical reaction. Okay, you want to balance this chemical reaction. Zinc and sulfuric acid is H2SO4, zinc is Zn. When it reacts, ZnSO4 and hydrogen gas is liberated. After writing this, you want to check whether it is balanced or not. So number of moles of reactant should be equal to the number of moles of product. Understood? So you can take this one example to balance the chemical reaction. Just check it out whether it is balanced or not. If it is not balanced, then you need to balance it. Done? and even this reaction is also important. What happens when iron, that is ferrous, iron reacts with water? What happens? It gives ferric oxide plus hydrogen gas is liberated. You want to balance this chemical reaction. Even this is also important. Okay, you can balance it. After balancing, next we can come here. Okay, so this question is important. Now what is that question? Can you see here? This is the reaction which represents photosynthesis, correct? So you want to write this chemical reaction. What is the chemical reaction during photosynthesis? That is 6 moles of carbon dioxide plus 12 moles of water in presence of sunlight and chlorophyll. It gives glucose, oxygen and water. Please write and practice this chemical reaction. Got it? This is one important question. Done? Okay. Next, come back to the next line. Here children, all want you all have to study these all textbook question answers once. You have to prepare for your textbook question answers also. You should not neglect. Okay, so you have to learn here. Why should a magnesium ribbon be cleaned before burning in air? Okay, why we have to clean that? And we have to balance this equation. When hydrogen and chlorine combines, it gives hydrogen chloride. He has given. Okay, you have to write their symbols and you have to balance it. And even here he has not given like hydrogen plus chlorine. He has given in sentence formation. This sentence formation you have to convert into symbols and then you have to balance in question number 3. Done? Okay. Next, types of chemical reaction. We have different types of chemical reactions such as combination reaction, decomposition reaction, displacement reaction and double displacement reaction. So these are the major 4 types. Apart from this, again we can see even we have sub reactions like exothermic reactions and endothermic reactions. Done? Exothermic and endothermic reaction. And after that, which type of reaction we have? Oxidation reaction, reduction reaction, both together. Oxidation and reduction both together we call it as redox reaction. So this is the total set of chemical reactions we have in this chapter. Now let me study one by one. We can see here the first type of combination reaction. Now here the question is, they may ask you what is combination reaction, give an example. That is one type of question. And apart from that, we can see there is one experiment is been done. Can you see here one experiment? Yes, that is formation of slag lime by the reaction of calcium oxide with water. Got it? So from this experiment you can expect a very important question. Okay, so let's see what is that. It's very important question, children. You need to remember this. What is that question? See here. When calcium oxide reacts vigorously with water. Calcium oxide reacts vigorously means very fast with water to produce slag lime. You should remember this. So what happens when calcium oxide reacts vigorously means very fastly it reacts with water to produce slag lime. So calcium oxide, when it reacts with water, it converts into slaked lime. Done? So calcium oxide is also known as quicklime. Remember this, calcium oxide is also known as quicklime. When it reacts with water, it gives slaked lime. Slaked lime means calcium hydroxide. So please remember these names. Calcium oxide means quicklime. Slaked lime means calcium hydroxide, and it will produce heat also. It will produce heat. Any doubts? So here the question is, what happens when calcium oxide reacts with water? It produces slaked lime. Got it? In this reaction we can see calcium oxide and water combine to form a single product. Correct? This is A and this is B. A means calcium oxide, B means water. It gives AB. It gives AB. When two different chemicals, when they combine together to form a single product, is known as combination reaction. Understood? So this is the definition of combination reaction. So you should remember this definition and you should remember this chemical reaction. Quicklime is known as calcium oxide and slaked lime is known as calcium hydroxide. Done? Okay. Now after this, still more important topics are there in this. See here, children. Please note this. Okay, this paragraph. What here it says that like a solution of slaked lime produced by the reaction. A solution of slaked lime like above reaction what happened, in that we produced slake lime, right? So this slake lime where we are using this for whitewashing walls, where we are using for whitewashing walls. You might have seen tiles, if it is dirt or something, we used to do whitewashing for that, right? So there we use slake lime, understood? And similarly here we can see calcium hydroxide, it reacts slowly with carbon dioxide. Okay, why we are using for whitewashing? Because sir, is it dangerous? No. Why? Because see here, calcium hydroxide reacts slowly with carbon dioxide. This reacts very slowly. This calcium hydroxide, slake lime, it reacts slowly with carbon dioxide in air to form a thin layer of calcium carbonate. On the walls. So it will gives us a dazzling flame. It gives us the shining surface on the wall. Got it? It reacts very slowly and it will give one more coating, one more layer it forms, that is known as calcium carbonate. One more new layer will form, that is calcium carbonate on the walls. So this calcium carbonate, okay, new layer which is formed, this calcium carbonate is formed in 3 days of whitewashing and gives a shiny finish to the walls. Understood? And interestingly, we can see the chemical formula of marble is also CaCO3. Remember. So here 2 things you need to remember. This slake lime where we are using for whitewashing. Why we are using for whitewashing? Is it dangerous? No, it is not so much dangerous, because it reacts very slowly with carbon dioxide in air. And which is the layer is formed? That is calcium carbonate. So what is the use of this calcium carbonate? This calcium carbonate gives us the shiny surface. Okay. And what is the chemical formula for marble? CaCO3. That's nothing but calcium hydroxide. When it combines with carbon dioxide, it gives calcium carbonate and water. Is this clear? Did you understood? Very good. Now let we solve the next topic. Okay. Now here we can see the next. Let us discuss some more examples of combination reaction. So which are those examples? Even these examples are important. First is burning of coal and formation of water. See, this is A and this is B. It gives AB. Just to remember like this. A plus B gives AB. A plus B gives AB. That's nothing but combination reaction. Carbon plus oxygen gives carbon dioxide. Hydrogen plus oxygen gives water. Got it? Okay. Next, another examples. Okay. Before go for the other examples, here we can define. After this, we can define 2 types of sub-reaction. That is exothermic reactions and endothermic reactions. So which are the 2 types of reactions? First is exothermic, and second is endothermic. So we have 2 types of reactions: exothermic reactions and endothermic reactions. Now what do you mean by exothermic? See children, very simple, very easy. Exo means exit. Exit का मतलब क्या बेटा? बाहर जाना. Means heat is released. Exit is nothing but going out. Means heat is released. Okay. Endothermic. Endo means ando means under, means inside. It means heat is absorbed. Simple. With the liberation of heat is liberated. Understood? So exothermic reaction means, in exothermic what happens? Heat is released. Exit. Remember this logic. Exothermic means heat is released. Okay. And here heat is absorbed. Okay. What is exothermic reaction? In a reaction, if the heat is released, such a reaction is known as exothermic reaction. In a reaction, if the heat is absorbed, then it is known as endothermic reaction. Okay. Now, one more definition also we can define for exothermic. If the reaction takes place inside, okay, inside the furnace or inside. Understood? If the reaction happens inside, that is known as endothermic reaction. If the reaction happens inside, inso means ando means under, under. If the reaction happens inside, that is endothermic reaction. If the reaction happens outside, then it is known as exothermic reaction. Outside reaction, exothermic. Inside reaction, endothermic. If the reaction we can see from our eyes, we can see what is happening. That is nothing but which is happening outside, that only we can see. That is nothing but exothermic reaction. And one more reaction is we cannot see the reaction. Example, you are moving in a bike. In the bike, The fuel is burning. Can you see the burning of a fuel, the combustion of the fuel? No, we cannot see. It means which type of reaction is happening inside the bike or inside any kind of furnace. We cannot see what is happening inside. That is nothing but endothermic reaction. Understood? So that is what. Still actually I don't have time to discuss with you with more number of examples. So just you can go with these things. So here burning of natural gas, burning of, please study this topic, it's important. That is burning of natural gas and why respiration is known as exothermic reaction or exothermic process. Why respiration is known as exothermic process or vegetation is known as vegetation is known as exothermic process. Okay, so this type of questions will be asked to you, so you have to be very careful with this kind of questions. Okay, so please you can read this paragraph once to understand in a better manner, and this is nothing but how respiration will take place. It has been given here. So glucose plus oxygen gives carbon dioxide plus water plus energy. So remember this. So this is the chemical reaction for respiration. This is a chemical reaction for respiration. Understood? Their photosynthesis we discussed and here respiration we discussed. And remember the examples of exothermic reaction and remember the examples of endothermic reaction. Examples of exothermic reaction in our daily life where we can see, like the type of questions also you will be getting. Such you have to write the headlines of this. Got it? And even remember, decomposition of vegetative matter into combust is also an exothermic reaction. It is very important. This sentence is been asked in the exam. So remember this sentence. The decomposition of vegetable matter into compost is also an example of dash. That is nothing but exothermic reaction. Done? Good. Next, after this, decomposition reaction. Can you see here what is exactly we are doing here? Can you see this figure? Yes, that is correct way of heating the boiling tube containing crystals of ferrous sulphate and smelling of odor and smelling the odor. Odor is nothing but smell. We are smelling we are smelling the odor. Okay. Now in this what is important is, children, please do remember what is important in this. The very important topic in this chapter is this. Yes, they will ask you this question. What happens when we heat the ferrous sulphate? When ferrous sulphate is heated, what happens? It gives ferric oxide, sulfur dioxide and sulfur trioxide. Remember, this is very important question, and they will ask you to balance this reaction also, and based on this reaction they can ask you n number of questions, such as, observe you. So what type of questions will be asked based on this chemical reaction? Let me see. You can see in this paragraph. Okay, so we can see here when ferrous sulphate crystal, that is, please remember this molecular formula FeSO4 7H2O. So this is the molecular formula of ferrous sulphate crystals. Okay, when ferrous sulphate crystals, when they lose water when heated, they lose water when they are heated, and color of the crystal changes. Remember, color of the crystal changes. So what happens? And it decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. Ferric oxide is solid, sulfur dioxide and sulfur trioxide are gases. This question has appeared. Okay, when we heat the ferrous sulphate, ferrous sulphate crystals, then the types of gases are produced. So which gas is produced? That is sulfur dioxide, SO2 and SO3. You have to write this. You need to write this. Which are the gases are produced when we heat the ferrous sulphate crystals? That is sulfur dioxide and sulfur trioxide. That is very important. You should not forget this. Got it? Okay. Here decomposition is nothing but opposite of combination reaction. In combination reaction, what happened? A plus B becomes AB. But in decomposition, it is opposite. AB becomes A plus B. Okay. AB becomes A plus B. Just you can remember this. Done. So decomposition of calcium carbonate to calcium oxide. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. This question is also very important. Okay, so which is the decomposition reaction is used? This type of decomposition reaction is used in various industries. Which type of decomposition reaction, children? That is decomposition of calcium carbonate to calcium oxide. Okay, and carbon dioxide on heating. When we heat calcium carbonate, calcium carbonate. Okay, once we heat this calcium carbonate, what happens? See here, this is here. That is calcium carbonate means limestone. When we heat this limestone, what happens? It gives us quicklime and carbon dioxide gas is produced. Got it? When we heat this limestone, what happens? It gives quicklime and carbon dioxide gas is produced. So this is used in various industries. Now can you see here this calcium carbonate? Okay, it is converted into calcium oxide and carbon dioxide on heating. It is an important decomposition reaction. It is used in various industries, and calcium oxide is also called as quicklime or just lime. It is also called as lime or quicklime. It is used in many uses in the manufacturing of cement. Remember this. So where we use this quicklime? We use in the manufacturing of cement. Got it? So this is how we are going to have the decomposition reaction. Again, in decomposition reaction we have different types. Okay, that is thermal decomposition. Thermal decomposition is nothing but if the reaction happens in presence of heat. Okay, we produce heat, so reaction is happening. That is known as thermal decomposition. So this is an example for thermal decomposition because we are heating. If you pass light, that is called as photochemical decomposition reaction. It is called as photochemical decomposition reaction. And here one more reaction is very important. What is that reaction? You can see here. Children, these are very important questions. Okay, so here we can see heating of lead nitrate and emission of nitrogen dioxide. It means when we heat lead nitrate, which type of fumes are produced? Brown color fumes are produced. We can see here. If you want, we can see here. Just a minute, I'll show you. This is nothing but brown color fumes. Children, believe me or not, these two reactions are very important reactions, children. That is your ferrous sulfate crystals and lead nitrate. Believe me, you can expect one question from this. Got it? So what is this? That's nothing but this reaction is very important. What happens when we heat the lead nitrate? When we heat lead nitrate, we get lead oxide, nitrogen dioxide and oxygen. So this nitrogen dioxide is a gas. So what is the color of the fumes are produced in this gas? That is brown color fumes. They will ask you this question. So what is the color of the gas is produced when we heat lead nitrate? When we heat lead nitrate, we get brown color fumes. So which is the gas is produced? That is nitrogen dioxide gas and oxygen. Understood? So lead oxide, nitrogen dioxide and oxygen. This is the products which is produced when we heat lead nitrate. Remember the two reactions, your up reaction and this down reaction, these both are very important. If we pass, if the reaction happens in the presence of light, that is known as photochemical decomposition reaction. Here we can see this reaction is happening within the presence of current. That is called as electrochemical decomposition reaction. That is electrolysis of water. Here you have to study what is electrolysis of water. Just define what do you mean by electrolysis of water. Done? Okay. Now after this we can see here in this reaction it is very important. We can see white silver chloride turns grey in sunlight. Remember this color. Colors are important. Here white color, silver chloride was there. It turns into grey. So here white color, this was white silver chloride. Once in the presence of sunlight, it has become silver plus chloride. Understood? That's nothing but what is the color of the product now? It is grey color. First it was white color. Got it? So this is one important reaction. Just to remember the colors of this. Okay? And after this we can see similarly silver bromide also behaves in the same way. Silver bromide in the presence of sunlight, it gives silver plus bromide. So here remember this, it is used in black and white photography. The above reactions, both silver chloride and silver bromide. Understood? And above this both the reactions we used in black and white photography. So remember the use of these both reactions. Got it? Okay. And here we can see, here in this both the reactions energy is absorbed. So hence this is an example of endothermic reaction. This is the example for endothermic reaction. Got it? Any doubts? Now you can solve these both questions. We can see here a solution of substance X is used for whitewashing. We have already done. So what is the name of the X and write its formula? Already we have discussed, right? Yes. Next is displacement reaction. Displacement reaction. Children, in displacement reaction what they can do is, they will most probably they will give you, okay, they will ask you what is displacement reaction or what is double displacement reaction, or write the difference between displacement reaction and double displacement reaction. Here what they may do is, usually this is the chances are there, they will give you this reaction and they will ask you to identify which is the reaction is happened. Very simple, just to remember A plus BC, okay, it becomes, see, A is positive, always the first number is positive, always the first is positive, that is A plus BC gives, always A is positive, B is positive and C is negative, okay, always this side positive and this side negative will react. Got it? So this side positive react with this side negative, again this side positive will react with this side negative, but here A and C combines, it becomes AC plus B is positive, but here in this side there is no negative, so we write just B. This is known as displacement reaction. This is known as displacement reaction. Okay, so you just remember these both reactions. Okay, so displacement reaction, they will give you this reaction and they will ask you to identify which type of reaction. Okay, so here you can just make out this. Zinc and lead are more reactive elements than copper, so they displace copper from its compound. So you need to remember this sentence. Done. And similarly double displacement reaction, same way, this is very important chemical reaction. They will give you this reaction and they will ask you to balance. If not, they will ask you to identify which type of chemical reaction is this. Okay, that is double displacement reaction. Here one thing is very important. During this reaction, one insoluble substance is formed. Insoluble substance is formed, that is known as precipitate, and this reaction is known as precipitation reaction. So double displacement reaction is also known as precipitation reaction. If any reaction that produces precipitate, not only this, if any reaction if it produces precipitate means insoluble salt or insoluble substances if it produce, then it is known as precipitation reaction, and this is the example of precipitation reaction. Very important question. They may ask you what is precipitation reaction, give an example, then you have to write this example. Done? Is this clear? Okay. And next, oxidation and reduction reaction. What is oxidation and what is reduction reaction? They will ask you this, or else they will give you some example like this. Okay, CuO plus H2 gives Cu plus H2O, just they will give you this and they will ask you to identify where oxidation is happening and where reduction is happening. You need to identify the oxidation and reduction reaction and which is the oxidizing agent and which is the reducing agent. Oxidizing agent and reducing agent also you need to identify. Two things, you have to identify where oxidation reaction is happening and where reduction reaction is happening. Second thing is you want to identify which is the oxidizing agent and which is the reducing agent in that, okay, in that figure. And after that, what is corrosion? So remember the color of the rust is reddish brown powder. It is reddish brown color. Okay, so here they will ask you what is rusting of iron and what is corrosion and how is rusting is different from corrosion. How is rusting is different from corrosion, and they may ask you so what are the causes of corrosion. You can just read this paragraph, you will get to know what are the causes of corrosion. Is this done? Are you getting, children? Good. Next, what is rancidity and what are the causes happens due to rancidity and what are the preventive measures? That questions will be asked usually, and which is the gas we are going to fill in chips packet so that we should not get smell. Okay, so name the gas, you have to write the name of the gas, and you can start studying this question and answers. I hope you all have understood this chapter, highlights of first chapter. Thank you for watching this video. Wish you all the best of luck, and next we solve the next chapter highlights. If you have liked this video, do not forget to like, comment, share this video, and do not forget to subscribe our YouTube channel, Evershine Coaching Groups. Is this clear? Fine. Wish you all the best of luck. From these areas, start solving some number of questions. Okay, definitely you will become expert in this chapter. Thank you.